Law of cosines is the next topic. Law of cosines formula that they give you is on the reference table. The form on the reference table states a squared equals b squared plus c squared minus 2bc times the cosine of a. The only thing that you need to remember about that is these two angles or letters have to be the same. You have to have side A with angle A. If you want to solve for B, your B's would switch with A and angle A. And if you want to solve for C, your C's would switch with A and angle A. So it would look like if you're solving for B or angle B, you'd use the equation b squared equals a squared plus c squared minus 2ac times the cosine of b. And if you were solving for side C or angle C, it would be c squared equals a squared plus b squared minus 2ab cosine of c. So remember, the first letter and the last letter have to be the same, side and angle. And when you're solving using law of cosines, the time you know when you're using law of cosines is when you know all three sides, so you know no angles whatsoever is when you use law of cosines, or you know two sides and the other angle meaning the angle in between them. So something like you know side B and side A, or side C and angle A. So two sides and the angle in between. So if I want to solve the triangle where angle A is 52 degrees, side B is 7 and side C is 13. First I'm going to draw the triangle. So I have my triangle ABC. I know side B is 7, angle A is 52, and side C is 13. So if I want to solve for the other sides, first I'd solve for side A, because I'm given angle A, so I would solve for side A first. So A squared equals B squared plus C squared minus 2BC times the cosine of A. Don't know A, but I do know B and C, so I'd have 7 squared plus 13 squared minus 2 times 7 times 13 times the cosine of 52. And again, that's degrees, so you want to make sure your calculator's in degrees. Since I know all of the right side of the triangle, I could type it right in the calculator. Chances are it is going to give you a decimal because you're typing in cosine of some random angle. So A squared is going to equal some big number, which is 105.9496115. And then to get A by itself, you would square root both sides. And you're going to ignore the negative this time because you're measuring a distance, so it can't be negative. And this is when you want to use the answer button in your calculator. So you type in square root and then second answer to get the decimal correct, which would be 10.29 for side A. And then if I wanted to solve for the other angles and the other sides, I could use law of sines and set up my proportion since I know both of my A's now. I could do A over sine A equals B over sine B. And then I could use A over sine A equals C over sine C to solve for my angle C and my angle B. And this example gives me all three sides, so this one's a little bit different and it requires more work. So I want to find the smallest angle whose triangle has the measures of 28, 34, and 47. The smallest angle has to be opposite the smallest side. So we're going to label this A, B, and C. You could really label it anyway. So since I want to solve for angle A, I want to use the equation A squared equals B squared plus C squared minus 2BC cosine of A, because I want to have angle A opposite my smallest side, which is side A. So now I can plug in what I know, which is all the sides. So I'd have 28 squared plus, or equals, B would be 47 squared plus C is 34 squared minus 2 times 47 times 34 times the cosine of angle A, because I don't know that. So if I simplified each of my parts, I would get 28 squared is 784. 47 squared is 2,209. 34 squared is 1,156. And 2 times 47 times 34 is minus 3,196 times the cosine of A. So if I was following order of operations, which is very important in this equation because I'm solving for angle A, which is multiplied by negative 3,196, these two have to stay together. So I can combine 2,209 and 1,156 because order of operations say I'd multiply first, so these two have to stay together and I can add these two. So if I add those two, I get 3,365. Again, these two have to stay together because I'm multiplying. I'm trying to find that variable, a. So I'd have to get everything else on the other side. So I'd want to minus 3,365. Which does give me a negative, but that's okay because I have a negative 3,196. So I get negative 2,581 equals negative 3,196 cosine of A. To get cosine of A by itself, I'd have to divide by negative 3,196. And it's okay if you have an ugly answer for that, because you have cosine of A is equal to that ugly thing. Negative divided by negative will make it a positive. So I have 2,581 divided by 3,196. My whole goal is solving for A, so I don't really care about what this fraction looks like. I just want to get A by itself, so I'd have to get rid of that cosine. So I could take cosine inverse of both sides to cancel out my cosine. So A is equal to cosine inverse of that horrible fraction, which can be reduced to a decimal. You just want to make sure you have enough decimal places when you're rounding. You don't want to round them off too soon. And I get 36.14, which if I round to the nearest degree, it'd be 36 degrees is my answer. So the try now problem this time is talking about a parallelogram. If you remember what a parallelogram looks like, it kind of looks like a slanted triangle, or a rectangle. So I have the sides 27 and 32. And if you remember about a parallelogram, the sides are parallel, opposite sides. So this would be 27, this would be 32. And the included angle would be 48 degrees. So that means the two angles, one of them would be 48 degrees, which would be the acute angle. So this is 48 degrees. And if you remember anything about parallelograms, opposite angles are equivalent. So if this angle is 48, this angle is 48. And then opposite angles along the base or the top of the parallelogram, those are supplementary, meaning they add up to 180. So if I had 180 minus 48, I would get my other base angle of 132. So I want to find the length of the longer diagonal of the parallelogram. So looking at the diagonals, this diagonal would be longer than this diagonal. So I'm looking at just this triangle, which is 132, 32, and 27. And I want to find this angle right here, or this side right here. So I can again label it A, B, C, making me solve for side B. So the equation you want to use would be B squared, because I have angle B, equals A squared plus C squared, because I know those two sides, minus 2AC times the cosine of B. So you could try that and bring it to class, or we'll do it tomorrow in class.